having to do with the senses. And it's all, at this point, like if you guys remember, when we first started the nervous system, it was super, super confusing and overwhelming, right? But hopefully by now, it's kind of like, yeah, we know, we could guess that. We know what's going on, right? Hopefully, yes, maybe, no? Okay. All right, so let's talk about our senses. Before we do that, let's understand what a sensation is and the difference between a sensation and the perception of that sensation, okay? So a sensation is actually the awareness of changes in your external, internal environment. Cool. It's something you feel, okay? That is a sensation. Your perception is your interpretation of that sensation. Does this make sense? Okay. So the differences between your sensation and perception is why people don't all feel the same things in the same way, right? Like I could smack Erica with this pencil. She's going to have a sensation, right? She may perceive that sensation as painful, pleasurable, it tickled, whatever. I could smack Jennifer with the same pencil in the same exact way. She'll have that same sensation, but she could perceive it as something different. So as Erica may see it as painful, Jennifer may say, no, that didn't hurt at all. That actually kind of tickled. Cool? Okay. So that's sensation, and then what you feel or how you interpret it, how you interpret that incoming sensory impulse is your perception of it. The pathway for these sensations will always be a sensory receptor that initiates a nerve impulse that goes up to be integrated up here, right, in your cortex, remember? Okay. Now, there are different types of receptors for each sensation, and we are going to talk about the different receptors and what they do. Every sensation is called a sensory modality. Every sensation is a sensory modality. So a sensory modality would be something like touch, pain, taste. Those are all sensory modalities, and each modality will have its own individual receptor. So we group them either into general senses or special senses. Your special senses are the ones that we should already know. Your smell, your taste, your hearing, your equilibrium. Those are all special senses. We're going to focus today on the general senses, and those can either be somatic or visceral. Well, what does somatic mean? What? Somatic means body. So anytime you see the word somatic, you know it's talking about a body, something in your body. What is visceral? Visceral means organ. So anything that is visceral will be organic. Organ referring to an organ, not organic like food. Be from your organs, okay? So y'all remember visceral pleura, right? And viscera means organs. So my somatic senses, those are things like tactile, which is touch, thermal, which is temperature, or proprioceptive, which we'll talk about. That's the orientation or knowing what your body is doing. Your visceral general senses will be pressure, different chemoreceptors that pick up on different chemicals in your body, stretch, nausea, hunger. Those are all coming from the organs, okay? Meaning, is my stomach empty? Is it full? Is my bladder empty? Is it full? Do I need to pee? Those are all visceral sensations from your viscera. And then we had the special senses. So, are people getting kicked out or just coming in late? Come on, nobody knows. Okay. All right, so all of these sensations will have a different type of receptor that is specialized in picking up that sensation and sending that impulse to your cortex to be interpreted. We're going to look at a few of them. Free nerve endings. Free nerve endings are the receptors for, oh man, she's having a day like me, receptors for pain, temperature, tickle, itch, and some touch. Those are free nerve endings. For me, the main one is pain. You need to make sure you know that free nerve endings are your receptors for pain. Okay, well, what does that look like? Simple. You have a sensory neuron right here. This is a sensory neuron, right? And at the right over here at the end of this axon, these are your actual receptors. That is just simply parts of the axon, those little flaked off like little fibers. Those are free nerve endings. Those are the ones that will pick up those sensations of pain, transmit it through this sensory neuron. Where is this cell body here? Do you guys remember? Dorsal root ganglia, right? And then it's going to relay over here on this end, either to a reflex through a motor neuron, right? Or maybe even a motor neuron and an interneuron and another neuron that takes it up to the cerebral cortex, okay? So over here, we may also have an encapsulated nerve ending. So here you have your nerve ending, but there is a special structure in yellow here that surrounds that nerve ending so that it either amplifies or give it a special way of sensing things. So these are encapsulated nerve endings, and they are going to detect things like pressure, vibration, and some forms of touch. So we've already seen this before. A good example of this is what? Do you remember the Pacinian Corpuscle? Have we not done the Pacinian Corpuscle? We've seen it, right? Yeah. Okay, this is an example of that. And again, goes through that, cell bodies in the dorsal root ganglia, goes into the spinal cord, and then relays onto the different neurons. Some of our receptors are super, super special. You'll only find them in one area. Things like your gustatory receptor cells. Those are the ones that are in your taste buds that react with the chemicals in our food. Photoreceptors. Those are your rods and cones in the eye. We'll do these with the special senses later on. And then you have those hair cells in the inner ear. Do you guys remember the hair cells in the inner ear, in the cochlea? We did those already in lab. Okay, good. So this is an example of what it looks like when you have a special receptor tied to this sensory neuron. So look, here it's saying sugar molecule. Is the sugar molecule the green arrow? I don't know. Here in orange, this little guy right here, that is your taste receptor. So this would be embedded into that taste bud, right? In between the two valleys, the taste bud. It is going to react with the chemicals. It's going to release its own neurotransmitter that relays onto the sensory neuron that then goes on to your CNS or your cerebral cortex to be interpreted. Okay. Another way of classifying these would be according to their location or what stimulus will initiate an impulse. And this is the stuff you need to know because we have three basic groups. We have extero receptors. What is extero receptors? Interro receptors, and then proprioceptors. Those are special. So extero and intero. Hello. Like extero, I can guess is probably on the outside, external. Intero is probably internal, right? And that's exactly what it is. Okay, so your extero receptors are your receptors outside, right? They bring in sensations that are coming from the outside world, okay? Things like, what do I hear? What do I see? What do I smell? What do I taste? Who's touching me? Who's pushing me? Vibration and pain. Your interro receptors are all on the inside of your body, okay? Does my stomach hurt? Is my muscle cramping? Those are all inside things that is giving you an idea of what's going on the inside of your body, okay? So your extero receptors are perceiving or bringing in sensations from the world outside of your body. Interro receptors are bringing in all the sensations from the inside of your body. Do we get that? Yes. Perfect. And then we have the proprioceptors. Those are on their own little category because those are the ones that tell us what our body's doing, what's our body position, are our muscles stretched, contracting, cramping, you know, is my finger moving, is my elbow bent, is it straight? It tells us what we're doing. This is why if I'm standing, I know that I'm standing without having to look and physically see my feet on the ground, right? Or if I hold one foot off the ground without even seeing it, I know I did that. I know my knee is bent. It's because I have these proprioceptors in my joints and in my muscles telling me that my leg is bent. Make sense? Okay. What time is class end? 12:50. I ask that every time, don't I? You guys, I'm sorry. The semester's almost over, and I'm still looking at my schedule every single morning. Not good. It's never going to happen. Okay, so the following slides are all lists that have the different receptors and what sensations they pick up on. Okay, you do need to know these. I know that we usually ignore these, but these you have to know. Okay. So your free nerve endings, what do they do? Pain. Free nerve endings, pain. Your encapsulated nerve endings, we're going to look at some special ones. Don't worry about it on here. We're going to look at the different ones like the Pacinian Corpuscle. Excuse me. And then your separate cells, we're going to take them individually. So exteroceptors, that's everything on the outside. All of the stimuli that I am perceiving outside of my body. Interoceptors, all of the stuff that's happening on the inside. Okay, am I getting enough oxygen to my muscles? Is my brain getting enough glucose? Is, you know, my stomach producing enough acid? All that's on the inside. And then your proprioceptors, those are all your body position and movement. What is my little toe doing right now? Oh, it's bopping up and down. Yep. That's what that is. Now, mechanoreceptors and thermoreceptors. Just by the name, you can kind of tell what kind of receptors these are. And these are according to the type of stimulus. So mechanoreceptors will be mechanical stimuli. Mechanical stimuli. What does that mean? Things like touch, pressure, vibration. Hearing is a mechanical stimulus because these are sound waves that are coming in, actually vibrating that eardrum, right? So that is a mechanical stimulus. Stretching of your internal organs, that's a mechanical stimulus. If you eat too much, your stomach is way out here, stretched out, that's a mechanical stimulus because it's a physical movement of that stomach wall that causes that. Thermoreceptors, what do you think they detect? Temperature, right? They detect temperature. Nocioceptors, what do they detect? These are the ones that respond to any painful stimulus. So you should always tie your nocioceptors to pain. Okay? That's a very important association. I can't make it even more defined. Nocioceptors, immediately think pain. If I'm talking about nocioceptors in the skin, you're going to say free nerve endings, right? Okay. Photoreceptors, what do you think they respond to? Light. Yeah. What about chemoreceptors? What do they respond to? Chemicals. So when we talk about chemoreceptors, your taste buds, those are actually chemoreceptors. They detect the chemicals in the foods that we eat, and that's what gives us that perception of taste, because that chemical starts an impulse and then it goes to the brain and then we interpret it as taste. It's kind of, it freaks me out a little bit to think that the things that we taste, the things that we smell, those are all chemicals, right? Like when you walk into a public bathroom and it smells bad, you are smelling what's happening is little particles of someone's poop is actually interacting, yes, with the chemoreceptors in your nose, and that is what's being interpreted as a smell. And we'll talk about that stuff when we go into the special senses, but it just freaks me out in the sense that, okay, so every time I smell something bad, I'm actually having this chemical that I'm perceiving as a bad smell react with my chemoreceptors in my nose, and that's what allows me to smell it. And not only that, but the idea of taste, things like taste and smell being perceived. Remember, you have a sensation with a stimulus, but then you have a perception. So how do I know that, or not how do I know? It's totally possible that what I think is sweet may not be sweet to you because you have a different perception of it. Is that not totally freaky? It is for me. It's cool. Yeah, but like you'll never really truly know what another person perceives because there's no way to get into their head, right? Like you can't put someone's cortex into yours and feel what they're feeling. So you never really know what another person is perceiving from their sensations. That's crazy. Okay, and then we have Osmo receptors. Those are the ones that are going to detect different changes in osmolarity. Yeah, and that is like in your body fluids. Also, you'll have some with your nose and your mouth, but those are the ones that are going to check.
Okay. I need to leave class early because
Watch the video. What's wrong?
My son's school called and he has a tick and they broke the head off inside, so now I get to take him to the doctor.
They broke the head off of what?
The head off a tick.
The head off
like
of
a
tick
thing that you get, like, I don't know, playing outside.
All right, go check on your son. You're fine. Watch the video later. Good luck.
Thanks.
Did anyone hear what that was? The head off of what? A tick? Okay. Well, okay. Okay, so out of this list, I do expect you to know what these do right here. You should be able to know that a mechanoreceptor is going to give you impulses or detect changes in mechanical things. Thermoreceptors are going to be temperature. Nocioceptors will be painful stimuli. Photoreceptors will be rays of light, and chemoreceptors will be chemicals. Okay, not really where they're at, just what they detect. The birds are after me today. They really are. Okay. Do what? Right? Supposed to be. Yeah. Can you tell I'm not a bird fan? I'm terrified of birds, y'all. That's my one irrational fear, and I don't know where it comes from because I used to breed birds, but I flip out over birds. Like oh my gosh. And then like a few weeks ago, I went into Lowe's on the beach, which I'm not a fan of Lowe's, but I love Lowe's on the beach. And I walk inside the building, and there were like 10 birds flying around over by the bird seed. And I almost peed my pants because these birds are just flying like crazy. I'm like, oh my God. To me, that is like the equivalent of being on the set of the movie Birds, you know? Like it may be just a few birds to some people, but to me, that was like the end of the world. I was like, I'm gonna die. How do I get out of here? Like I froze because I didn't know which way to go where the birds wouldn't go. And they were just all like pecking at the bird seed. Birds are psycho. Anyway. Yeah, that's what I get for going to Lowe's, you're right. I only go to get planks of wood for the Airstream. You know, every time I go, I ask them for a sample. They hand me one. Here, just take it. So I just keep going every time I stop by, and eventually I'll have enough flooring to do the whole thing. That's my plan. If anybody works at Lowe's, you don't know who I am or what I do. Hey, I've got a lot so far, and I've got the kids doing it now too. So every time my daughter goes to the beach, she's come back with the plank. And I was like, you and your friends all go in different times, and everybody come out with a plank of wood for me. I don't get paid enough. Y'all should bring me wood. That's the way it should be. Bring me some planks of wood. All right, let's talk about somatic sensations. Remember, our sensations were somatic or visceral. Somatic was the body. right? Visceral was the organs. Thank you. Our somatic sensation, she just texted me, she must have heard me. Oh. Our somatic sensations are things like touch, tactile is touch, temperature, pain, proprioception. Those are all somatic sensations. And then we have tactile sensations, touch, pressure, vibration, itch, and tickle on the surface of your skin. I do want to understand this concept right here. We want to talk about it just for a minute because it is actually super cool. The idea that our receptors can undergo adaptation. What does that mean? It means that a stimulus can continuously excite a receptor, but that receptor eventually is going to stop listening. Okay, so even if that stimulus is still there, you're not going to have that perception anymore. It's going to stop listening. Examples of this, if you say, some of us have like chronic pain, right? Let's say you have something that, like something that pops up on your body, like a little pimple that hurts or something, and it just constantly hurts, and then after a day or two, you don't feel it anymore. Well, it's adapted. Something else, like you are, let's say you're sitting in a really tight chair, and it's uncomfortable because you feel the pressure of the chair on you. If you sit there long enough, you won't be bothered by it anymore because those receptors will adapt. I can't think of a good example. Somebody give me an example of adaptation. Nothing's coming to me right now. Oh, I have a good one. I have a really good one right now. I do. Okay. You know how nobody really knows what their house smells like, right? You know that. You for sure know that because you live in this home, you're there all the time, right? And then you take a month vacation and come back, that's when you smell your home. Because you're like, oh, has my home always smelled like this? What does this smell? It's always smelled like that. But what changed is you were away from it for a while, so that stimulus disappeared for a while, so that adaptation that those receptors had done was reversed. Okay, make sense? Or like if you're going somewhere and there's a bad smell. I'm telling you all right now, we all live here. We are all adapted to the smell of the paper mill. We don't smell it anymore. We think it's not so bad until it gets really, really bad. It's here all the time. The smell is there. We just don't smell it because our smell receptors have already adapted to the smell. So that's what it means to have adaptation. Our receptors have the ability to ignore a stimulus when it is repeated over and over and over. Okay? Make sense? Okay. It's just a cool little thingy there. I don't know why my phone's going off the hook today. It's like all of a sudden everybody, what is this? Oh, it's pharmacy. Okay, so let's talk about a few of these. We're going to take just a few of our sensations and break them down. We still have time if we do. Okay, and the first one we're going to talk about is pain, the sensation of pain. There are actually two types of pain. There is slow pain and fast pain. So fast pain is what we also call acute pain. Slow pain is chronic pain. Fast pain can be sharp. It'll come on suddenly and it'll hurt bad. Okay, it's acute. It's a stabbing pain all of a sudden that I got on my side. Slow pain is that achy, throbby pain. You know, I have a stomach ache and this is kind of painful, but it's not so much, it wasn't like all of a sudden I got hit by, you know, or I got stabbed by a knife and bent over in pain. Cool? Okay, so we got fast pain and slow pain. Now, our somatic pain, the pain that comes from our body is usually fast pain. And your somatic pain can actually be superficial or deep. Superficial will be everything on the surface, right? Like your skin. And deep will be the somatic pain that comes from things like your muscles, okay? Those are all usually fast pain. Your visceral pain, that's the pain that comes from your organs. That's most of the time a slow pain, right? Very rarely do you all of a sudden fall down like, oh, my intestines, oh my God, what was that, right? It's usually an ache. It's usually, man, I'm not feeling comfortable. I'm bloated. My stomach hurts. Something's going on, but it's not like this fast, sharp shooting pain that knocks you out most of the time. Sometimes it does happen, but most of the time it's not. Okay. Are we cool with this so far? Yes? Okay. Visceral pain, the one coming from those organs, can also be referred pain, right? So most of the time, visceral pain is felt in certain areas of the skin or the skin overlying the organ or just deep to that. Things like the liver and gallbladder on the right shoulder, the lung and diaphragm, right part of the neck, the heart goes all the way down the arm, the gallbladder, the stomach. Make sense? The kidneys, that's the flank pain, front and back. So that is how we perceive visceral pain. So while my kidneys, I may have a urinary tract infection or a nephritis or something in the kidneys, and I can't exactly tell you that it's in the kidneys, but I can tell you that my back hurts, right? Or let's say I have a dull, achy pain in my right shoulder. That's nowhere near my liver, but it could be my liver. That's where I would perceive that pain. And we already know that because we've already talked about referred pain and dermatomes, so this should not be confusing to us at this point, right? Okay. All right. Proprioception. I think we can do it. Okay, remember, proprioception was what? It was the idea of knowing what my body is doing when it's doing it, right? Is my leg bent? Is my leg straight? Am I walking? Where am I going? What am I doing? My head turned, tilted? That's proprioception. So we have proprioceptors. Those are the ones that will actually pick up on that sensation and give us that information. They are embedded in our muscles and tendons. And these three here are different types of proprioceptors. The muscle spindles are proprioceptors that are found in your skeletal muscle, and that's going to tell me what my muscle length is doing. Okay, this is the one that if the muscle fiber is stretched, the muscle is going to contract, right? Because my proprioceptors have said the muscle has stretched. And those are your muscle spindles. They're actually embedded within the muscle. We have tendon organs. Those are proprioceptors that are found in the tendon, right where the tendon and muscle meet. And those are the ones that are going to tell me what's going on with that tendon. Is the muscle stretched to the point that now the tendon is being stretched? Sound an alarm, we're overstretching. I have, proprioceptors in the joint called joint kinesthetic receptors. Coming. Okay. And those are going to give me an idea of what the joint is doing. Is the joint flexed? Is it extended? Is it rotating? Okay, so you actually have little proprioceptors inside of your joints and around your joints to tell your body what it's doing. So all three of these, your muscle spindles, your tendon organs, and your joint receptors will all feed this information to your cortex so that you have awareness of what every part of your body is doing as far as movement and position. Cool? Okay. And we should have a picture. Yes, here is a picture of all three of those. I'll let you look at that on your own. Here's your tendon organ. Notice this red part obviously is the muscle. This white part here is the tendon. Here's that tendon organ embedded inside of it, telling our body what this tendon is doing. Is it stretching out? Is it too stretched? Is it torn? What's going on? Right here, this is a muscle spindle embedded in the muscle itself, and it's going to tell my CNS or transmit that idea of what my muscle is doing. Is it stretched or is it relaxed? Is it whatever's going on in there? Okay. And then, let's see, this is a chart of my different tactile receptors, things like your Meissner corpuscle. Remember, Meissner was touch, Meissner massage. That's the only one on that page that I need you to know. And then it goes on through all of them. You don't have to know all of these. We've already talked about the ones that you do need to know, but you can read through those if you want. But really, I would make sure you know Meissner or your corpuscle of touch. Make sure you know your Nocioceptors for pain. Your muscle spindles will be your muscle length. Your tendon organs will muscle tension. And then your joint receptors will be your joint position. Okay?